you guys, everybody pull out, and I know that some of you might be sharing the paper that you just got. It says homework. Now that's technically not homework because Friday was a little bit of a disastrous class on solidifying these two-way tables and their conclusion. So I was not happy with that. That was really like the one thing in this class that I kind of get like turned around on, and I figured it out. So I'm not a common sense person, so I had to write this down in all these different formula ways, and I finally figured it out. And then after I did, I was like, that was an easy way, and if I had any common sense, I probably would have figured that out from the beginning, but there you go. So I want to go through a full one of these problems where you are trying to identify if things are related or not. And your ultimate decision is going to be if the variables are independent or not independent. Okay, so let me take you through one full example of what I want to make sure you want to include and what you don't. First, let's put in these, you need the sums. So let's go ahead and add these up. So the total for firearms is $18,169. Okay. The total for poison is $5,825. The total for hanging is $4,375. The total for other is $2,038. And the total is $30,407. So that's the total. All right. Now, I actually had done some of the problems down here, and I don't want to show you this. So here's what the debate was and the confusion was with me up until I got this finally figured out. You have to pick a marginal distribution. That's an overall way, an overall summary of the rates. And so in this case, I would like to pick overall summary of the method. So I would go like 18,169 divided by the total. The total for poison divided by the total. Hanging divided by the main total. Okay? So this ends up giving you the overall, the marginal distribution. Okay. Once you have that overall, then you compare a conditional to the overall. And here's where we weren't sure. Which way do you need to do your totals? Do you need to go left to right or top to bottom? And here's the answer. If you are doing your marginal top to bottom, then you do the other two subgroups also top to bottom. So these are the two subgroups of the overall group. So the male is a subgroup and the female is a subgroup of the total. So therefore, since I put my numbers top to bottom, then I would do my male values. This would be conditional upon being a male. Then you would figure out the firearm, poison, hanging, all those things would be conditional and they would be out of the male total. And then with the female, firearm for the females, poison for the females, hanging for the females, other. So you're going to then always go the same direction that you went as your marginal. Ta-da! That's it. Doesn't that seem easy? And like, how did I take so long to figure that out? So let's put some of those numbers to that and actually then finish out the summary. Okay, so the first I did was the marginal. Let's look at those. Okay, this is marginal by method. Okay, so you're going to write these down. So marginal by method, the way I got that, okay, the way I got marginal by method is by the total for firearm out of the total for the whole everything. Okay, so that's how I got that. And that percent is 65%. Okay, let's look at how I got poison values. You can fill those in. These poison values, 5825, that came from right here. Total for the poison up here, out of the overall 30,407, and that's 19%. Okay, so I'm going top to bottom. Good. So, and then the hanging overall is this 4375 over the total. Other 2038 over the total. Okay, so that is my marginal because it's the summary of the methods overall. Summary of the methods overall. Alright, so now I want to do the conditional. And it's conditional upon being a male or a female. Because if I go top to bottom on my summary, I go top to bottom on my subgroups. Top to bottom on the subgroup. Okay? So my first subgroup is male. So tell me the firearm numbers for male. 15,656 divided by 24,078. Correct. And that comes out to be 60%. Okay, so then next, poison number for male, 3403 over all of the males. Hanging for males is, I didn't put the numbers there, but what numbers gave that 15%? I started just summarizing. What number gave that 15%? 3588 divided by the total for the males. Okay. So that was, there are your numbers overall. I went ahead and I just kind of skipped to the percentages. So figured you could do that. So hanging for males was 15%. Other for males was 6%. For females, the you can see the firearms was 40%. Poison is 38%. Hanging 12%, and other 10%. So fill those in so we can now talk about what do you compare. I don't know. Go in front of a train, a good car accident or something, I don't know. Just trying to figure out what's other. Yes? 21 plus 19 is yeah, wait. It's how much? Is that really? Yeah. Okay. Here we go. No, we're going on. No. Okay. Why is it that way? Because it has to be 100%. So did I just like compute something a percentage wrong? Male is only 95. There's decimals. I wouldn't imagine decimals counting for that much. But okay, then my guess. Okay, listen up. My guess would be that somewhere I like did some addition wrong here. I don't know. I'll have to figure that out. But those should have come out to 100 because we had all of the parts of the whole. So I don't know what that is. I'm gonna have to take the time and I'll figure that out at a later time. Yes. It would be an observational study. Yes, I would not impose a treatment upon that. Okay. All right. So let's go on. So maybe there was some little mathematical fluke because those should be 100% since your fractions were all part of the whole. So something happened, maybe the sum was wrong, I don't know. All right, now let's talk about what do you compare. Once you have marginal and once you have the conditional, we need to talk about what to compare. So what kind of things should we compare? What do you think? Compare a conditional to the marginal, correct. Do not compare conditional to conditional. So do not compare your male rates to your female rates. You are comparing a conditional to what is supposed to be happening overall. Okay. So based on male's firearm being 60%, that's not right. Is this one 65 and that one 60? No, it's this. I just switched. I'm sorry. That fixes everything. Okay. Sorry, I had switched them on the paper. Okay. So back to our conclusion. I can see that because males have a rate of usage of firearms at 65%, and overall firearms are used at a rate of 60%, then what's happening? I can say that males are what? They're more likely to use firearms. Good. They are using firearms at a higher rate than firearms overall. In fact, there's 8 statements that could be made. Let's say a couple more of those. So let's say we're comparing this 14%. What am I comparing that 14% to? Okay, that's 19%. So what statement would you say when you're comparing this 14% conditional for males to the overall 19%? Say it. Correct. Good. Males are using poison method at a lower rate than poison method is used overall. In fact, if you compared the female rate, look at this female rate of 38%. Females are using poison the rate twice as much as overall. Okay? All right. So there are many, many statements. There's 8, in fact, that you could make. Let's now go to our conclusion. All right. I want to walk you through kind of like a formula of the paragraph that I want you to have and the information that I want your paragraph to have. This is a summary that leads you from the data to your conclusion of independent or not independent. Here we go. The first thing I want you to do is tell me if there's some relationship between the 2 variables. Now, what were the 2 variables in this situation? One variable is gender. Very good. The other variable is method. Okay. So gender and method are our 2 variables. So would you say, based on our percentages, that there is a relationship between your gender and your choice method? Yes. Would you say yes? Okay, very good. So I want that to be your first sentence. I want you to say, there appears to be a relationship between gender and method. Okay. Next, I want you to give me 2 facts. I want them to include numbers, and I want them to be specific. So, and you have 8 to choose from. I personally would pick, the most compelling, most striking differences that there are. So, what's the difference that you would like to say up here? Let's use this one and this one. Okay, so let's do 2 mathematical sentences. So this first one you told me is males are choosing firearms at a higher rate than firearms overall. Because that's what you're comparing to, firearms overall. And I want the numbers. 65% versus 60%. Okay? The second sentence I wanted to use was that one about the females, because that was quite striking on the female usage of the poison. So, how about this? Females use poison at twice the rate of poison overall. See how I'm always comparing it to that category overall, and then give specific numbers. That was 38% to the 19%. Okay. So then your final statement is that conclusion of independence or not independence, and I want to lead you down the right path, because frequently our brains say this. We go, and I understand the logic behind this. You say, well, they're different from each other. The numbers are different, so that means if they're different, then they're independent of each other, and that is not correct. So let me lead you down the correct thinking pathway. Here it is. The numbers are different, so something's happening. Good. So method and gender are affecting each other. So they are connected. If they are connected and they are affecting each other, then what's the conclusion? Not independent of each other, because they are connected. They are pulling each other in either direction. They are not independent. So that's the pathway. You think, are they affecting each other? This is kind of what your brain is thinking. Are they connected? Okay, that's going to help. So this is like what your brain is thinking. That's going to help you say then this. Gender and method are not independent. Okay? That's your final on that. Okay, very good. Now, you got this homework today. You picked this up today. Let's look at this problem, please. I like this problem, even though I don't think these are really realistic numbers. The other values I took in this packet are actual factual data. I like to use that whenever possible. Okay, the reason I liked this is because it related a Venn diagram to the two-way table. So let's take a look at this. This is a comparison of employment, status, and ownership of a smartphone. So let's look at this Venn diagram. One circle owns a smartphone. One circle is the employment status. So owning a smartphone status and employment status. Those are the two variables that we have. Okay. What would this 25 in the middle mean? They are employed and they own a smartphone. Good. And that's what this says here. They are employed and they own a smartphone. Okay. This 68, however, would be what? Employed and do not have a smartphone. So that would be here. Employed and then not having a smartphone. Okay. Look at this 3. These 3 do what? Own a smartphone but are not employed. So these own a smartphone but are not employed. And the final 92 do what? Neither. They do not have a smartphone and they are not employed. Okay. So what you will do for this is it says find the marginal distribution for ownership status. Which way are you going to be doing your numbers if you're doing for ownership status? Top to bottom. Okay, so if you do this overall, top to bottom, how are you going to do the conditional? Top to bottom. And then you will be comparing ownership status to owns to not owns to not owns. Okay, next. Let's look at this. This is actual data about the Titanic. And there actually are more numbers than you need on this. And I did that on purpose. I left all those there because I want you to think about what values you really actually need. So what happens is, since this is a problem not asking about is there a difference between your gender and your survival rate, it asks is there a difference in your class and your survival rate. So therefore, this is extra information. We're actually not interested in the breakdown of the males and females and children. Okay? What we're interested in is these totals. Okay, so I gave you some information here. The total of the lost column is 1503. So if you go down here, the total of all of those numbers in the lost column are 1503. The total of all of those summaries classes in the saved column is 703. The total for the ship was 2206. So, my first question is, how would you find the marginal distribution by class? Good. Class total divided by the total. Good. That would be your marginal. And so then, can you tell me which direction I would do my conditional? Would I go across? Okay, I'm going to go top to bottom for lost, top to bottom for saved. Those are going to be my conditional ones. All right, very good. So those are both the two-way table, independence versus dependence, or bad. Independence versus not independence. Remember, we do not say dependent. All right. The next two problems are about this new thing called Simpsons Paradox. Have I talked to you about that period? I don't think so. So that's why I asked you to have your notes out from Friday. So have out your notes from Friday. Okay. Again, the notes look like this. They're chapter 2-3 notes. Then the second to last page is about Simpsons Paradox. Okay. In fact, let's see here.